Thanks for coming to this talk. Good morning. So today I'm going to tell you a little bit about LinkedIn's journey adopting deep learning on Hadoop. So a little bit about me. My name is Anthony. I've been at LinkedIn for about 5.5 years. A fun fact, once you hit your 5-year mark, they give you this data dinosaur t-shirt. It has a little picture of a dinosaur on the back. Over my 5 years, I've worked on a few different areas of the Hadoop stack at LinkedIn. First on the scheduler called Azkaban, which is open source. Then on our data access layer built on top of Apache Hive. We call it Dolly. And in the past year, I've been working on machine learning infra. So I'll tell you about that this talk. A little bit about LinkedIn. Most of you have probably used it. Our vision is to create economic opportunity for every member of the global workforce. And one way we're doing that is to create an economic graph that includes all of the members, you guys, all the companies, all the jobs, all the skills you need, all the educational institutions, et cetera. And as you can see, we operate at a pretty massive scale, and there's a lot of data there. And so naturally, we do some machine learning at LinkedIn. Most of you have probably used our app either on the desktop or the phone. Here are some of the services we offer that are backed by machine learning. So the people you might want to connect with, jobs you might want to apply for, your news feed, or your recommendations for classes you might want to take on LinkedIn Learning. These are all powered by machine learning. So initially we start out with more traditional models like decision trees, linear models. But with those models, you might find that as your data increases, your performance tends to plateau. But with deep learning and deep networks, generally as your data grows, the prediction of those models tends to improve as well. So we've started using deep learning as well over the past couple of years. When you first start looking at deep learning, there's tons of frameworks out there. I've listed a few out there. This is a graph, a tweet by a director of AI at Tesla, and it shows the mentions of popular machine learning frameworks in machine learning papers in the past few years. This graph goes until February 2018, but the trends have been similar recently. So at LinkedIn, we wanted to build an end-to-end solution, and we chose to focus primarily on TensorFlow. So that's what I'll be focusing on this talk. But in the future, we may support other frameworks as well. Keras is also a higher-level API that works on top of many of these frameworks. And in TensorFlow 2.0, Keras is now the official API for TensorFlow. All right. How many of you guys are like machine learning engineers or data scientists? So about half of you. So as you guys know, like the machine learning pipeline is not just the model. It's not just training the model. There's all of this other stuff that goes into it. So here I've created a simple diagram. You have your data ingestion, your pre-processing, extracting your features before you actually get to your model training. And after you've trained your model, you still have to figure out how to deploy it and serve it in production. And so there's a lot of engineering that goes into it. And at LinkedIn, our goal is to allow AI engineers to iterate through this experimentation loop as rapidly as possible. So as fast as they can think of ideas, they can test them out and deploy them. So our initiative is called Productive ML or Pro ML. But for this talk, I'm going to primarily focus on model training. That's the part that I've been working on. All right, so go back about 2 years, and AI engineers approached us. I'm on the Hadoop dev team, and they said, "Hey, we want some GPUs. We want to do some deep training." So what we did was we set up some machines with GPUs installed in them, and we told the engineers, here are some GPU machines, go do your training on them. But if you ever try to do distributed training on raw hardware, it's actually pretty tedious. You have your model code, you have all of the dependencies like TensorFlow and all of the Python libraries you're using. You gotta ship all of that to all of the machines you're training on, and then on every machine, you have to specify like all the other machines. Every machine needs to talk to everyone. So you need to specify the host and port for all of those machines. And then on each machine, you have to tweak a little bit. One machine is PS0, parameter server 0. Another is worker 0, worker 1, etc. And so as you can imagine, this is like pretty tedious and very error prone. And if you like update your model code, now you got to update it on all the machines. And then you're not sure if it failed because you forgot to update one of the machines or if there's a bug in your code. So we imagined we could do better. Really, you want something to orchestrate all of this nitty-gritty stuff so you can just focus on your model code. Another challenge was with all these AI engineers competing for the same machines, you only had like 1 or 2 GPUs per box, and if multiple engineers tried to run on those GPUs at the same time, you would sometimes run out of memory on the GPU and get some sort of out-of-memory exception. And finally, like you want to integrate your model training into this whole machine learning pipeline. You want to have data preprocessing, model training, and deployment all in the same workflow. So that was another thing we were trying to do. So LinkedIn is a Hadoop shop. We store all of our offline data in Hadoop. And Hadoop has HDFS, the storage component, and Yarn, which is the scheduler. And we've invested a lot in Yarn, and it has some pretty cool features. So GPUs are important for machine learning, and Yarn added GPU support in 3.x, which I've shown here. We definitely want to take advantage of that. Next, Yarn has this notion of queues. So you can split up your cluster across different organizations. Here's a toy example where we have this relevance queue down here. That's what we call our AI org. And under the relevance org, you might divide that up into the ads org and the search team and the jobs team, et cetera. And you could have separate top-level orgs for the Hadoop team, for business analytics, et cetera, et cetera. So this is a very powerful feature of Yarn. And of course, it's not great to just statically divide your resources because people have different workloads at different times of the day. So you want to take advantage of elasticity so that queues that are busy can take advantage of the free resources that other queues have. So in this example, the AI6 queue needs more resources than it's guaranteed, and it can just use the free capacity in other orgs. And finally, Yarn lets you set user limits, so a single engineer cannot use our whole cluster. They're entitled to just a fixed max percentage of their queue. Yarn continues to be developed in open source, and there are a lot of upcoming features that are useful. There's been a lot of work on Docker support in Hadoop so that you can run any Docker image you want in Hadoop. And you can imagine using that for machine learning as well, just packaging up your virtual environment, all the Python libraries there as well. Yarn native service is this idea of being able to run anything on Hadoop, whether it's a long-running service or a batch job. You just need to specify a short config file, and then off it goes. And finally, in the latest version of Hadoop, there's this new machine learning command line called Submarine, which has now been split out into its own sub-project. So these are things we're thinking about taking a look at going forward. So we're a Hadoop shop. We want to do deep learning at scale in a scalable way. So how can we do that? As I showed you, Yarn has many great features for scalability in general. And so we looked out into the community to see what kind of open source solutions people had come up with. And I've listed a few here, which I'll go a little bit more into. So the one most of you have probably heard of the most is Kubeflow, which is a machine learning toolkit that runs on top of Kubernetes. And it has a very rich ecosystem and one of the most active communities. However, like I said, we're a Hadoop shop. And though we're exploring Kubernetes, right now it's still in the early stages, and we're not ready to do it at a large scale yet. We have some pretty big Hadoop clusters going up to about 6,000 nodes, And Kubernetes currently hasn't been tested at that scale yet. Also, we run Hadoop with security enabled, and it'll take some work to integrate that with Kubernetes as well. And Kubernetes has this notion of namespaces to kind of divide up your resources, but they don't support nested namespaces the way Yarn supports nested queues. Then there are the Spark-based solutions. You might have heard of TensorFlow on Yarn, sorry, TensorFlow on Spark, or Databricks' deep learning solution. And this is great if you're already using Spark and you want to do some pre-processing in Spark and then feed it into a machine learning model directly, and then take the output and continue processing in Spark. So Databricks provides some converters between Spark and TensorFlow. But however, there are some challenges which include a lack of a GPU resource support until Spark 3.0, which I don't think has been released yet. At LinkedIn, we're still on 2.3. And also, Spark has a homogeneous model, in which I mean you have a bunch of executors, and all the executors have the same amount of memory and CPU, all the same resource requirements. But for machine learning, you usually have workers and parameter servers, and you need different resource requirements for each. And that's not easy to do in Spark. Then there are the Yarn native solutions. Other companies have had similar problems and have developed some solutions. So two that we came across were TensorFlow on Yarn from Intel. This one, I think, was like a hack day project. There hasn't been any activity on it for over 2 years. Then there's this other one from a Chinese security company called Keqiu. Their solution is called X-Learning. And so the good thing about these solutions is you can run them on Hadoop right out of the box, and they just work. But again, neither of these have integrated with Yarn's GPU support, which was added in Hadoop 3. Then there's Horvad from Uber, which sort of wraps an existing framework. This runs on top of TensorFlow or PyTorch. And you can take an existing optimizer in, say, TensorFlow and wrap it with Horvad's distributed optimizer. And now you can do this distributed synchronous training. And the way it communicates between the workers is by using MPI or NVIDIA's Nickel library. MPI is a message passing interface, popular in like high performance computing. We took a look at running this on Yarn, but in order to get like multi-node MPI working on Yarn, you kind of have to set up Docker with SSH as well. And finally, there's Yarn native service, which I alluded to earlier. This is available in 3.x. And so you can just write a simple YAML file that specifies your workers and parameter servers, and if you need GPUs, and then Yarn will take care of all of the other orchestration for you. Easy in principle, but setting it up requires setting up this Yarn DNS registry so that all of the workers have static IP addresses and Zookeeper. So it's a little bit a challenge to set up. And we're still using Hadoop 2.x as well. So this feature is not quite in 2.x yet. And so here I've kind of summarized all the solutions we looked at. There's more out there, but this gives you a good flavor of what is available. And so in summary, like we want something that works on Hadoop, works on Yarn. We want something with GPU resources, resource support as well. So as you probably guessed, we ultimately decided to build our own solution, which we called Tony. And since we started out focusing on TensorFlow, we called it TensorFlow on Yarn, or Tony for short. But we've since added PyTorch and Horvad. So now Tony is just Tony, or if you want to have it expand to something, you can say things on Yarn. So we built our own solution. So the easiest way to explain Tony is to compare it with some other frameworks that you're probably familiar with, like MapReduce or Spark. So MapReduce has two kinds of tasks, mappers and reduces. And the mappers send their outputs to the reduces, or the reduces pull them from the mappers. And then in Spark, it's homogeneous. So you have one type of task, executors, and it's all-to-all. They shuffle data between stages. But for machine learning, you want flexibility to have arbitrary number of task types and arbitrary types of connections. So we designed Tony to be very flexible so that you can spin up arbitrary tasks, foobar, cux tasks, and it's up to you, up to the framework, how they want to connect with one another. So to illustrate some of the models that are possible with Tony, here are some common machine learning models. One common task is you want to generate like an embedding for each of your LinkedIn members. And so this is something that can be parallelized very easily. You want to do parallel scoring. And in that case, the tasks don't need to communicate with one another. Then you have the standard worker parameter server model, where the workers do the training and then send the updates to the parameter servers, which aggregate them, and then send the updates back to the worker. Then you have models like what Horvath uses, where there's no parameter servers. The workers just communicate with each other in sort of this ring architecture. All the workers do their training, and then they keep sending their updates in a loop until all the workers have all the updates, and they can average them and continue. But Tony is really flexible. We can support even like more exotic setups. In TensorFlow, with the newer API with estimators, you actually have more than just workers and parameter servers. There's also a chief worker, which takes care of checkpointing and synchronization, things like that. And you also have the option of adding an evaluator task that will periodically run your model on a validation data set to see how it's doing. On the right here, I've also put this hypothetical model where imagine you have like a huge, some data you need to look up and load into each of these workers, but it's too big to fit on a single machine. So you need some distributed database to store all of this data. So you can imagine using Tony to kind of launch this distributed hash table in some of the tasks, and then all of your worker tasks can then hit these distributed hash table to pull the data on the fly. And something like this is possible as well with Tony. And as I mentioned earlier, Tony supports many frameworks. We started with TensorFlow. We gave a talk before, and the first question was like, do you support PyTorch? And then that motivated us to add PyTorch support, and then we've added Horvath since then. But as you can see, our framework is very flexible, and if you want to run it for other frameworks, it's very easy to add as well. All right, so now let's dive a little bit under the hood about how this works underneath. So I'll take you through the anatomy of a Tony job. So you start with a client where you submit a description of your job, your config file, to this Yarn resource manager. That's the master that manages the entire Yarn cluster. It receives your job and spins up the application master, the brains of your job. And this is running in a Yarn container. And then the application master reads your config, asking for 3 workers and 1 parameter server, talks to the resource manager, hey, asks it, I need 4 containers. The resource manager gives you those containers, and the application master spins up the task executors in those containers. And then those executors then run your actual machine learning job, whether it's TensorFlow or PyTorch. Here we have 2 workers and 1 parameter server. And once that Python process starts, then it's all TensorFlow code. They use Google RPC to communicate with one another. The task executors, they'll monitor how the container is doing and then send back metrics and heartbeats to the application master, which can log those metrics out to HDFS. And finally, the client can pull the application master to get the latest status of your job and know when it's completed. To make Tony work with Yarn, we had to do a few Yarn changes. We maintain our own internal version of Yarn. And so we're on Hadoop 2.x. And so we took the 3.x GPU support in Yarn, and we backported it to Hadoop 2.x. And we're actually leading Hadoop 2.10 release. And that should be coming out in the next few months. And it will include the GPU support. In addition, Yarn has this notion of a tracking URL, which is boxed in red down below. And this tracking URL usually directs you to a summary page showing you the number of mappers and reducers. But in case of a machine learning job, you usually want to visualize your training progress. So we added a patch that lets you update that tracking URL, and we've made it point to TensorBoard when you're running a TensorFlow job. And that makes it easy to track your progress. This patch has also been contributed to both Hadoop 2 and Hadoop 3. All right, so how do you use Tony? It's really simple. We have a command line interface. You have this Tony jar. That's a fat jar with all the dependencies inside. And you just specify your Python virtual environment and your source code where your model code lives, and a config file. And that's it. And once you have that, you can run your job. The configuration file looks something like this. It's quite simple, actually. Number of workers, number of parameter servers, and if you want to run with GPUs, you can specify those. And we have a list of all the configs here on our GitHub. So as I mentioned earlier, it's not just workers and PS. This could be tony.foo.instances, or tony.bar.gpus, or tony.baz.memory. So it's really flexible how you want to configure this. And for every kind of task, you can specify a different command that you want to run. Once you've entered that command and kicked it off, the Tony client will submit your application to Yarn and then provide links to take you to the Yarn UI, as well as the link to the tracking URL, which will redirect to TensorBoard. We also provide links to the parameter servers and workers directly if you want to see, if you have any log output, such as your steps per second or the training accuracy, you can go there as well. So while the job is running, we emit metrics to HDFS, and then those HDFS metrics are then read by this UI called Tony Portal, and which will list all of your Tony jobs that have run, as well as the configuration that you ran with. So you can think of this as a history server for Tony jobs, a la the MapReduce history server or the Spark history server. So when you're doing machine learning, you want to use all these tools in the ecosystem, right? Notebooks, visualization, et cetera. Well, it's really easy to launch these tools inside a Hadoop cluster using Tony. All Tony requires is a Python virtual environment or a Docker image that has this stuff installed in it. And so if you create a Python environment with, say, Jupyter Notebook in it, you can just launch that inside the Hadoop cluster and then start using a Jupyter Notebook. Or you can open up, launch TensorBoard or MLflow, whatever you want. So it's very flexible. We want to empower our AI engineers to use whatever libraries they're comfortable with and iterate quickly. So Tony is open sourced. We open sourced this last year. You can find it on our GitHub. And we do welcome your contributions. We hope to integrate this with other services and cloud providers going forward. If you want to learn more details, you can check out a paper we wrote for the Operational ML conference that happened 3 days ago in Santa Clara, California. Or you can check out our engineering blog post. we've also started integrating Tony with other projects as well. As I mentioned earlier, we use Azkaban to orchestrate our workflows, and Azkaban makes it really easy to define a workflow that includes data preprocessing, model training, deployment, etc. So you can have a workflow that does Spark for data preprocessing, and then has this Tony job that's circled that does your model training. And after that, if you want, you could deploy that model to a production server. At LinkedIn, we also open sourced another project called Dr. Elephant. And Dr. Elephant is a doctor for Hadoop jobs. So it will analyze your job's counters and configurations and provide advice about how you can better tune your job so that it runs more efficiently. And so we've added support for Tony jobs as well for Dr. Elephant. So it could tell you whether you're actually using all the memory you request. You know, it's common to see engineers be like, oh, I need 100 gigabytes. You know, they just throw a big number out there and hope it works. And then it probably does work, but they're probably using way more memory than they actually need. And so Dr. Elephant can like flag that and suggest to the user, hey, maybe you can use a little bit less memory. We've also partnered with some folks at Google to make Tony run on the Google Cloud. So they have a service called Dataproc that lets you run Hadoop and Spark jobs on Google Cloud. And they've provided a setup script that gets you up and running using Tony on Google Cloud. And you can check out their blog post here as well. As I mentioned earlier, there's this new machine learning command line tool for Hadoop called Submarine. And Submarine is just an interface, and they want it to work for any machine learning framework, PyTorch or TensorFlow, et cetera. And so Submarine is the interface, and the actual implementation, they have two implementations. They have one that uses Yarn native service, and then we've added a second implementation that uses Tony. So we've added this Tony runtime in Submarine 40, and it will be part of the up-and-coming Submarine 0.2 release. And then LinkedIn is owned by Microsoft, if you didn't know. And we're working with the Microsoft Azure team to integrate and run Tony on Microsoft's Hadoop solution called HD Insight. Cool. That was a lot about Tony. And so now I'd like to show you a quick demo of really how easy Tony is to use. And this is a bare bones demo just using the command line. So let me just open up my screen. Great, you can see that. I have a Yarn cluster running on my machine. You have the resource manager, and you have a single node in the cluster. And so I have a demo directory right here. So I was running it this morning. I can get rid of some of this. So all you need to run Tony is this Tony fat jar with all the dependencies. And inside the source directory, you have your model code. So I'm using an MNIST example from the TensorFlow open source. I got it from here. And this is a convolutional neural network, a bunch of model code, and then we have this snippet here that starts TensorBoard. So Tony will find a port for you and then set the environment variable, and you can launch TensorBoard there. And then here's our main method. This is actually using the old API. It's a little out of date. It just has a parameter server and worker. I'm using the low-level monitor training session API. Nowadays, people tend to use the estimator API. So that's the model code. And now let's take a look at the config file, Tony demo. I haven't set up security locally, so I've disabled that. And I'm just using one parameter server and 2 workers. And if your machine has GPUs, you can enable GPUs very simply by just specifying one GPU per worker. And so finally, I have my Python virtual environment that has TensorFlow already installed. And so I have the magic incantation written here. So this is kind of what I showed you earlier. It's a simple Java command line that includes the Tony jar, includes the Hadoop stuff, your Python code, your virtual environment, and your config file. And then that's all you need, and you can just kick that off. And as you can see, Tony has submitted your Yarn application, and this is running locally. So we can open this up in a browser. So this is the Yarn UI. So Java's been accepted, and it's probably, so even though this is running locally, what Tony does under the hood is when you run this command here, Tony will actually bundle up all the stuff, the Tony jar, your code, and your virtual environment, and ship that all to your Hadoop cluster. So it's a little bit of overhead locally because I'm doing all this unnecessary copying. But if you're running in a real Hadoop cluster, you need to copy this stuff to HDFS and then copy it to all of the nodes that you're running your job on. And Tony takes care of this under the hood. So now my two workers and parameter server are starting. And so as you can see, my job is running now. And so Tony also prints out these direct links to the parameter servers and workers. So we can just go directly to the worker log. Let's see. OK, I'm not sure why that's not working. But OK, so the job is running. And as you can see, TensorBoard is starting. And it's getting ready to start training. All right. So as I mentioned earlier, once TensorBoard is started, we have this tracking URL link to TensorBoard. I'm not sure what's up with my proxy settings. But as you can see here, TensorBoard is running. We provide a link to it, and you can visualize your training here. You can see the graph of your model, et cetera. So it's very, very simple to use. And if you're using Azkaban, you can also run Tony jobs in Azkaban. And I've provided a YouTube link here that you can check out. So in the future, we want to add more metrics, integrate that with Dr. Elephant, such as GPU metrics. And we want the Tony portal to become a one-stop shop where you do all your machine learning stuff, launching notebooks, visualizing, managing experiments. And we want to make Tony even easier to use, have an interactive command line, sort of like Submarine, where you can interactively launch and monitor jobs, and provide a Python API so you can call this all from a notebook and make it really easy to use. We're integrating Tony with Microsoft's HD Insight, and we hope to work with people in the community to make Tony run on other frameworks and cloud services as well. So that's Tony in a nutshell. I think we have a few minutes left, so I'll take any questions that you might have. Yes?
What sort of changes do you think you'll make as you move to Hadoop 3x?
Yeah, so I think we'll probably focus more on Docker. That's something we're currently not running. And maybe switch to using Yarn native service under the hood or Submarine. But yeah, I think we should be able to make those changes without impacting what users see. They can still use the same APIs. Yeah, thank you. How soon? So this is a chicken and egg problem where all the big Hadoop companies with big clusters, no one wants to be the first to move to Hadoop 3. But some people are starting to test it out. I think right now we're focusing on a Hadoop 2.10 release, which I mentioned, where we're going to add the GPU support and a whole bunch of other features too. And I think we're going to move to 2.10 later this year, and then maybe next year we'll move to Hadoop 3. Yeah. Cool. Any other questions? Yes.
I know you mentioned that you have been running your own version of Yarn. So
yes.
If you were to immediately use it, so what's the Hadoop version we should be using?
Yeah. So the open source Tony is compiled against Hadoop 2.7. So if you're using like Cloudera CDH, I think they're on 2.6 or 2.7. I think Tony should just work out of the box with CDH. However, that version of Hadoop won't have GPU support, but that's okay for a lot of models. You can just use more CPUs. But yeah, Tony should work with that 2.7. Yeah, so we started developing Tony in 2018, and it's been almost a year now, I think. And so people have been using this in production for like over half a year, like six to 9 months now. We open sourced this back in September last year. Yeah, so this is the like de facto solution at LinkedIn for distributed training. Any more questions?
So is there any binding on using particular version of TensorFlow, or is it up to us or the developers?
Completely up to us. You provide your own virtual environment, any TensorFlow version you like.
Yeah, because the TensorFlow 2.0 is coming very.
Yeah. You could use one TensorFlow version, your partner can use a different one, etc. Yeah, it's very flexible. Yeah. And in the future, like once we support Docker, Tony supports Docker. If you're running Yarn with Docker, it'll work. But like we haven't really used it at LinkedIn. But in the future, we want like AI engineers to just provide their own Docker images with whatever they want and just be able to run that.
But I guess we can do that since there is a support for MLflow, for example.
Sure, yeah. If you want to use MLflow, you can add that to your Python virtual environment and use that. Yeah. Is that a question or just resting your? Okay. Yeah.
I actually do have a kind of question.
Yeah.
When you launch your Yarn containers,
Yeah.
Kerberos and everything is getting set up.
Yes. That's right. Yeah. And yeah, Tony takes care of that under the hood. And it's really easy to disable security if you're not using security, as I showed in my demo.
Follow-up question on that. So if you are on HTTP 3 or
Yeah.
Hadoop 3 and have GPU support,
Uh-huh.
will the open source version work use that standard GPU support?
Yes, I believe so. Like if you're on Hadoop 3.1 or newer, I think you get that GPU support out of the box. Yeah.
You have to recompile.
Yeah, actually, you probably don't even need to recompile Tony. Yeah. Yeah, yeah. And so the way Tony works with multiple Hadoop versions is we use some like Java reflection magic to like check if the GPU support is available, and then if it is, we'll use it. Cool. Thank you guys very much.